Hello, Professor. My name is hw6, and this video is to explain the question 1 of homework 6. It has 5 questions. The first question let us to find A so that fxy could define a valid joint density function. So we know that according to the definition, the integration of the jointly density function equals to 1. So it runs like this one. And then we solve that A equals to 4. And this is the answer of question 1. And then the second question asks us that xy correlated. Show my answer. And so we know that according to the definition, if two random variables are uncorrelated, means that the joint expectation of these two variables equals to the expectation of each vector's multiple. So we use integration to calculate it. So for the first equation, the answer is 1 equal to 9. And we found that the expectation of x and the expectation of y are also 2, 0, and then it's not equal, so they are not uncorrelated. For the third question, that finds the xy are independent or not. So if xy are independent, it means that fx multiple fx fy equals to fxy. So from the question 2, we know that they are not independent. For the fourth question, find the joint density function of x power and the power of y. Now we use the method of joint density function that lets two variables to equals to x, the power of x or the power of y. Then we use the Jordan metric to calculate this one. And then we solve it and talk about the range of z and w. So when z less than 1 or z less than 0 or z larger than 1, or w less than 0 or w larger than 1 is equals to 0, so it's not in the range of this one, not because it taught us that x and y are all less than 1 and larger than the negative 1. So this is equal to 0. Then when z larger than 0, less than 1, and omega larger than 0, less than 1, and we get the Jordan matrix equal to this, and then we use the equation to solve the joint density function of fzw, and because this have could solve four groups of answer of the value of x and y. So this equation are formed by 4 different parts, and then we solve it and let the value of x and y, z or w in it, and then we got the answer. Then the third question let us to prove or disprove that the power of x and the power of y are independent. So we use this function to solve the merging density function of fz and fw, and then we got this answer. So we found that the multiple of this one equals to this one, and the power of x and the power of y are independent.